Hey guys, welcome to day 66 of Codeforces Everyday until GM. There was no video yesterday, sorry about that. I just didn't have a lot of time to record a video, but I was able to do 3 questions throughout the day, so not breaking the streak. Was still working on Codeforces. Today we're back at it again. Let's do some 1200 rated and jump straight into it. I really want to do a new contest soon just to evaluate where I am. I've been working a lot on 1000 to 1200 rated problems, and I'm not too sure if I'm getting better because I'm stuck within some of these questions are really easy and then some of them are really hard. So I guess I can only really evaluate myself with a contest. But I don't know. My spring break is kind of ending. I do want to put out some shorts. Um, just get back in the groove of doing shorts, just because it brings a lot of new viewers to the channel, and it allows me to review problems that I've done and take a look at it again and be able to explain it. Really makes me understand the problem better. Um, so that might be part of the reason why I'm not seeing as much improvement as the earlier episodes. Of course, I've been plateauing for a little while now, but it's only been 2 months. I do expect to get better pretty soon. I think I am 1200 rated. I think if I can do one more contest and I can do A and B fast, and just complete C, I can jump straight to 1200. I might be coping, but that's how I've been feeling lately. When doing problems, I just need a contest time that works for me where I can prove that. But nevertheless, let's just keep doing problems, I guess. Okay. Rudolph has registered for a programming competition that will follow the rules of ICPC. Rules imply that for each solved problem, a participant gets 1 point and also incurs a penalty equal to the number of minutes passed from the beginning to the moment of solving the problem. In the final table, the participant with the most points is ranked higher, and in a case of tie, with lower penalty is ranked higher, okay? In total, N participants have been registered for the competition. Rudolph is a participant with index 1. It is known that M problems will be proposed, and the competition will last H minutes. A powerful artificial intelligence has predicted the values T, I, J, which represent the number of minutes it will take for the ith participant to solve the jth problem. Rudolph realized that the order of solving problems will affect the final result. For example, H equals 120, and the times to solve problems are 20, 15, 110. If Rudolph solves the problems in the order 3, 2, 1, 3, 1, 2, then he will only solve the third problem and get 1 point and 110 penalty. Okay. He'll solve the first problem after 20 minutes from the start, second after 15. He will not have time to solve the third. Therefore, he will get 2 points and a 55 penalty. Okay, that makes sense. He will solve the second problem, not have time to solve the third one, thus he will get 2 points and a 50-point penalty. So he's kind of gaming the penalty system like this, right? You want to maximize your points and minimize your penalty. Rudolph became interested in what place he will take in the competition if each participant solves the problems in an optimal order based on the predictions of AI. It will be assumed that in case of a tie, penalty and points and penalty, Rudolph will take the best place. Okay, so first line, T equals input, int input for in range T and MH equals map int input split Okay. There are n lines, each containing m integers for line in range n t or just call it a equals list map int input split. Okay, that should be the test cases then. For each test case, output an integer, Rudolph's place in the final table if all participants solve the problems in optimal order. Okay. Number of participants, number of problems, and duration. The number of minutes it will take for the ith participant to solve the jth problem. Okay. He'll solve the second problem after 15 minutes, the first one to 20, so 35 minutes. And the penalty is 15 plus 35. Okay. So how can we optimize the penalty points? Okay, and which one is Ralph? Because these are all the different participants, right? We want to output Ralph's place. Or Rudolph's place. Why have I been calling him Ralph? With index 1. Okay, he's the first guy. He'll get 2 points and 50 penalty points. Why 50? $20. Isn't it? He solves 15. So he gets 2 points, yeah, but 35 penalty, no? Where's 50 coming from? Oh, 15 plus 35. Yeah, that's right. One problem, 90 penalty. 3 problems, 240 penalty. Okay. If n equals 1, print 1, continue. This is for the case if there's only one participant. Alright, so the third case. Now for the rest of them, we have to look through This is constructive algo data structures DP greedy sortings. DP. Some sort of prefix array. Like, do we just calculate a prefix sum for each time? And output a tuple? Thinking we have a scores array and then do we have to calculate? I'm not too sure where to start with this question. Like, I can see the brute force pattern, but it's obviously DP, so that's obviously slow, right? In participants, in problems, each contest, duration. Okay, so getting the best score is obviously like we have to sort the list, right? And then we have to store the solved and penalty. We can do it in like a tuple or something. And do like sorted. Hmm. I'm just trying to visualize this problem. Okay, like if it's just okay, we need to calculate their score. Like okay, solved and penalty. Track like a timer. 0 for num in for time in a if time plus timer is greater than h break. time plus equals, or timer plus equals time, penalty plus equals time, solved plus equals 1. And then we append the as a tuple solved. Oh my god, why is it doing this? Penalty. Okay. Now we need to sort it by most solved. Okay, higher penalty. Lower penalty is better. So these are like reversed. And if they're tied, the lower index. Okay, we need to track the index too. Right, and then this is reverse. These are like opposite parity, so we can make one of these negative, like this, and then line is greatest. It should sort from greatest to least. So the greatest is now the least, and then, or least to greatest. Sorry, penalty should be least to greatest, and then line should be least to greatest. Okay, yeah, these are all the same parity, and then scores dot sort. And then print scores. Uh-oh. End of file when reading line. Here. I understand. We don't read in the... Okay, maybe... Can we just take this out for now? Might drop it back in here. Well, you have to read the lines anyway. I don't think it breaks anything if it's just one. It should still get sorted. But that fixes the end of file error. Now, is this correct? -3, so 2. 0. Okay, we're looking for a position 0. So we want to print... We want to iterate through scores. Look at score 2. And check if it's equal to 0. If it is, we print that out. So for I in range for I in enumerate scores, if score score 2 is equal to 0, print I plus 1, break. Okay. This should work, right? It's pretty straightforward. I didn't really implement a DP. I wonder if this is fast enough. I would just go through each case, find the solvent penalty, and then sort it. And then look for 0 and output it. Okay, score is not defined. Scores, yeah. Didn't mean that. Now this fails on this case. Which case? Second to last case. 3, 2, 27. This. Expected output is 2. Because it would be solve 2 problems with a penalty of 17. Wait, am I calculating penalty correct? $15 plus 20. So it should be, okay, if it's 1520, it's 15 plus 15 plus 20, which is equal to 55. So if it's 8, 9, it should be 8 plus 8 plus 9, which is equal to 25. I'm not doing penalty correct. Time, it's plus equals penalty plus time, I believe. This should fix it. There we go. The question is this fast enough? Wrong answer, okay. th expected 2, found 3. This doesn't even show 13 cases. Okay. So this is a test case issue. It's 35. I don't think this changes anything. It just makes it 50. What's the penalty for 3 problems looking like? Let's do 15, 20, 25. It should be 15 plus 15 plus 20 plus 15 plus 20 plus 25. Is equal to 35, 60. There's not really a case where we have a triple penalty, is there? This one maybe? No. Okay, let's just do 3 small numbers. 2, 3, 5. Our penalty should be 2 plus 5 plus 10. I get 19 instead of 17. Is it just penalty plus equals timer? Because timer should be 2, penalty would be 2, then 5, then 10. Is this right? 17. Okay, that might be the bug. Small bug fix. Alright, hope that's it. Not much changed. Feels too straightforward though, this problem. This problem was 1200 rated. I didn't really get stuck on anything. It was a pretty straightforward problem. It wasn't logically difficult. It felt like just implementation. Like sorting, I guess. Hardest part was knowing how to order the sorting. Right? Like I gotta get a TLE or something on this. Right? But I mean, it shouldn't. It's O and log n for sorting, I would say. Like if you're sorting, you're expected in log n. Okay, we got it. Bit of a hiccup with um the time. I guess misspelled it. Timer, whatever, with the bug, but it wasn't a hard problem at all. That was a pretty simple 1200, I would say. It took me about 33 minutes, but like even like 1000 rated takes me about 33 minutes. So 30 minutes. Okay, let's do another. Dude, I don't know why, but every single time I sit down to do problems, like my stomach starts killing me. I did go to a sushi buffet yesterday, and I have not used the restroom since. At least, not number 2. Might be coming up. We should have enough time for one more problem, and then I'll go use the restroom, I guess. Destroy the toilet. But, yeah. Given an array A consisting of n greater than 4 non-negative numbers, you need to perform the following operation on A until its length becomes 1. Select two indices, L and R. 1 is less than or equal to L, less than R, less than or equal to absolute value of A. Replace the sub-array between AL and R with a single integer, the mex. Been a while since I've done a mex problem. Contest problems always like to use mex for some reason when I'm doing them. Where mex b denotes the minimum excluded mex of the integers in B. That's pretty straightforward. Let x equals mex of A. Okay. The array will always become A12 L minus 1 x A R plus 1 R plus 2 A absolute value A. Okay. Note the length of A decreases by R minus L after this operation. Serval wants the final element in A to be 0. Help him. More formally, you have to find a sequence of operations such that performing these operations in order, the length of A becomes 1 and the final element in A is 0. It can be shown that at least one valid operation sequence exists under the constraints of the problem, and the length of any valid operation sequence does not exceed n. Note that you do not need to minimize the number of operations. Alright, so we have infinite operations. Okay, let's take in our input. Then we take in n equals int input, and then A equals list map int input split. Okay, maybe I do need to run to the restroom before this problem's done. I don't know, I'll try to hold it, but if I can't, I might just go and come back. I don't really feel like ending the episode on 36 minutes. Okay, what is going on? For each test case, output a single integer, the length of the operation sequence. Then output k lines containing the two integers, the indices you choose in the ith position where a absolute value a donates the length of the array before this operation. Multiple answers, print any of them. Okay. Select two indices, L and R. Replace the subarray with a single integer. Perform the following operation on A until its length becomes 1. Replace the subarray with the max. Okay. Well, let's just look at an example. In the first test case, 1, 2, 3, 4, max is 0. After only one operation, the array becomes 0, and it's a single integer, so we're done. Second test case, okay, hold on. Maybe I can't hold it after all. I'll be right back, guys. Okay, I am back. I did a quick run. We'll probably have more later, but we gotta go finish up this video before anything, so. Okay, where were we? Looking at test cases. The second test case, we chose this. That was the next, right? Replace. Okay, select two indices. Given an array A consisting of n greater than or equal to 4 non-negative, following the operation on A until its length becomes 1. Select. Now, why do we need absolute value of A here? I don't understand. When will A ever be negative? Replace the subarray single integer max, where xb denotes the minimum excluded max of the integers b. Okay. Once the final element in A to be 0, you have to find the sequence of operations. At least one valid exists. Okay. So, in order for the max to be 0, you need a subarray with 1 in it. Like, can't you choose this? And the max is 2, and then 2, 1. We'll skip straight here. What did they say about duplicates? Nothing, right? You do not need to minimize the number of operations. We just need to find a way that works. And makes it 0. Okay. Let's choose. Wait, this is an interesting test case. What if we had 0, 0? Oh, it's at least 4, right? 0, 0, 0, 0. We would choose this, 1, this, 1. How would you do 0, 0, 0, 0? Okay. Test case 3. 1, 2, 3. Hit it 6. Alright, 1, 2, 3, 4, 5, 6. 5 and 6. 1, 3 and 4. 1, 1 and 2. 1, 1 and 3. Oh, 0. I see. 0, 0, 0, 0 would be like this. Right? If we can get it all ones. Huh. Alright, so 1, 2, 4, choose everything 0. 0, 1, 0, 0, 1. 2, 1. We're going to do 1 and 0. Right. So do duplicates even matter? Also, we need find operations. Like, I don't really know how to start with this problem. You need to find the number of operations. Okay. So, in all these other cases, we've made it an array full of ones. That's what these three cases have in common. Right? They're an array full of ones. Now this one, 1, 2, 3, 4, can we do that? We can make it an array full of ones because 2, 3, 4. No. 0. 2, 3, 4, the minimum expected value is 0. So it should be a permutation of like 1 to n. Duplicates don't matter. Okay. Oh, there also can't be a single 0 in the final array. So we will always want to pair 0 with something. Pairing 0 with something will create 1. Okay, so the final array has to be all non-zero, and we can do that by pairing zeros with anything else. Okay. The only problem is this 6 zeros test case. Like, I would say greedily pair zeros with stuff, but you can't. That's not it. I have 2 zeros. It's impossible. 3 zeros. It's possible. 4 zeros is possible, but our constraint is 4 or greater. So how does that help us with this case? 0, we can do 0, 0, 0. Well, we can group 0, 0, 0. We can group 0, 0, 0 and 0, 0, 0. Mm. Hmm. Okay. What does this tell us about the problem? I feel like this 0, 0, 0 is a hint case. 0, 0, 0. Like okay. We do this, this, this. We can also do this, this. We can also do, okay. We can also do this, this. One, two, three, four. No non-zeros, so this one passes immediately. 0, 1, 0, 0, 1 has zeros. So what? All these. What groupings do we have? We have this and this. We have this and this. We have this. We have this, this. A ton of groupings. One, two, 0, 1, 2, 3, 4, 5. 5, 4, 3, 2, 1, 0. I want to get rid of zeros. We can do it by this. Do it by this also. Well, not everything. One, two, 1, 2, 1, 4. This one we did 1, 2, 0, 1, 0, 0, 1. 1, 2, 1, 2, 1, 2. Okay. this one is the fourth test case. Four five 1 4. 4 5 4 5 1 4. 5 4 3 2 1 0. 4 5. We did 4 5 again. Wait, 4 5 is 3 zeros 1. They don't need to do all that. Just do this. Okay, they low-key only have to do operations on zeros. But we can't greedily do zeros, as shown from 6 zeros case. What about half of the zeros? 3 zeros? So there's 3 zeros in here. We're allowed to take 2 zeros. What? This doesn't make sense. 1 0 here. What kind of pattern is it? It's just zeros. So what do we need to reduce the array down to? We need to reduce the array down to, we need at least 2 numbers. They all need to be greater than 0. Wait. Yeah, because if it's 2, 2, and it's still 0. Next. So we just need 2 segments. Just split the array in half. Boom. 0, 0, 0. 0, 0, 0. 1, 1. Both greater than 0. Next is 0. Right? Wait, Loki, this might work. 5, 4, 3, 2, 1, 0. Boom. This is 0. This is 3. That I get. Okay, so we only max the 0. We only operate on the 0 set. Like if it has a 0 in it. We don't need to max this. So boom, and then we max everything. So our last operation should always be 1, 2. We store the state of the array, split it in half, check halves for zeros. Okay, no, we at most only need 3 operations, right? Give an array, split it in half. So let's do check zeros. If 0, operate, and then 1, 2 at the end. If no 0, we just operate on. If there's no zeros, then you can just 1, 2 call it or 1 in. It's not 1, 2, 1 in. Call it a day. I think this is it. So we given an array. Split the array in half. Right. We can do n divided by 2 and n divided by 2 plus 1. We need a max function. Let me think about this. Okay. Okay. Print LR. No. No plus 1. Okay. Now is greater than 0. L equals max L. R, and then operations dot append 1 n over 2 operations dot append we should do the right side first because that doesn't affect the left side. Right n over 2 n. Right there, like this. Then op dot append len 1 len L plus R. Print len operations or operation in operations print operation star. Okay. Of course, first time always fails. Int has no one 4. Then our next case is 0 1 0 0 1. Split it here. 0 1 2 5. Okay, I also need to this isn't 2 5. 1 2 3. This is 3 5. 0 1 2 3 4. It's plus 1 over n, and then 1, 2 should be correct. So it's 3, 5, 1, 2. This is 2, 2, 0. Okay. Next is 6, 0, 0, 0, 0, 0, 0, 0, 2. 1, 2, 3, 4 to 6. It's 1, 1 to 4. 1, 2, 3, 4. This ain't right. 4, 6, 1, 3, and 1, 2. Wait, this is right. Which case am I looking at then? Okay. This one, 3, 5, 1, 2, 4, 6, 1, 4. 4, 6, 1, 4. 6. 1, 2, 3. 5, 4, 3, 2, 1, 0. 4, 6. Then 1, 4. Yeah, this is right. Okay, I low-key think this is right. Double check the last two cases. 0, 0, 1, 1, split it in half. We take this side 1. So it's 1, 2, and then 1, 3. And then 1, 0, 0, 0, split it in half. It's 3, 4, 1, 2, and 1, 2. Yeah, this is right, this is right. And we got it. Look at that. Wasn't too bad. It was a little bit rough. Like, figuring out what to do was a little bit rough for this question. Implementation was not hard at all. But, yeah, we got it. It took us 40 minutes. I did take a dump in between, so yeah, I mean, it was definitely faster than my other 1200 rated questions. Alright, if y'all enjoyed this video, be sure to like and subscribe. I'll see y'all guys tomorrow. Bye.